Hi guys, I'm going to do a little tutorial video about atomic structure and Bohr atom diagramming. This is an assignment that you have in your Google Classroom that you're to complete, but I'm just going to go over a few things to make sure that you have full understanding. This is an example of one of the element tiles. This is for oxygen. And things that we know about this just from looking at this tile is this number up here that's on the top, this is the atomic number. And this number is specific to the element. There's no other element that can have the atomic number 8. So in this, you would just have atomic number. This is the element symbol, the O. This is the element name. And this is the element's mass. And so it would be called its atomic mass. Over here, it wants you to break down the things that you know. What two parts of an atom does the atomic number represent? Well, from the atomic number, the first thing that we know is we know how many protons that an atom has. But also, if we're just talking about an atom, we're not talking about an ion, and we haven't got into that yet. Protons and electrons are equal to each other. So this is also going to be our electron count. But the next thing is how to determine the number of neutrons that you would have for each atom. And how you're able to do that is that the overall mass of an atom comes from the two particles that are inside the nucleus, which are your protons and your neutrons. So if this number right here is equal to protons plus neutrons, and this number up here tells you how many protons you have, then you can take this number and subtract it from this number and be able to determine your amount of neutrons. I do suggest to round your masses. So you would look to the right of the decimal, and if this number to the right of the decimal is 5 or greater, then you would round it up. Just as this one is 15.9, you would round this up to 16. So in order to determine its mass, you would say 16 minus 8, and you would also have 8 neutrons for this atom. Neutrons are not always equal to your protons and electrons, but they are in some elements. So how do you figure out the number of neutrons? You say atomic mass minus the atomic number, and that's going to give you your number of neutrons. So if you went to this one, I'm not going to put all these down, but if we went to this one, we know from looking at the 6, we know our P and our E is 6. And then we're going to look at our mass in order to get our neutron count. And since we have a mass of 12.0, we're going to just call it 12. When we say 12 minus 6, our neutrons are going to be 6. Neon's going to be very similar. Protons and electrons both 10. And then our mass is 20.1, so we're going to keep it at 20. So 20 minus 10, our neutrons would be 10 also. Potassium, for potassium, our proton and electron count would be 19, but this mass is 39.0, so it would stay at 39, and we would say 39 minus 19, and we would have a neutron count of 20. So this, our proton and electron would be 19, and our neutron would be 20. So that's just an explanation of how to break those down. Now, Bohr atom diagramming. Some of you guys, especially you remote guys, have not really got a lot of instruction about this, so I want to go over it with you for a little bit. There are some rules when it comes to Bohr atom diagramming. The electrons is what we will primarily be diagramming. The protons and neutrons can just go on the inside of the atom, and you could literally just put, like, say for carbon, you could put 6p6n inside the nucleus. But our electrons, we actually have to place them on either, they can be called energy levels, it can be called orbitals, sometimes it's called the electron cloud. You'll hear it called numerous things depending on where you're receiving the instruction. But it's where the electrons exist. So here's the rules that you have. The very first energy level or orbital can only hold 2 electrons, but the second energy level can hold up to 8. It is not full until it has 8 on it. So you would never have a third energy level unless you had at least 11 electrons, because 2 plus 8 is 10. And then if we went on and we had an 11 to 18, those would exist on a third energy level. I'm not going to try to sketch these, but just for help for you, I would use shapes and use circles and drop them and pull them to do these. The drawing is going to be much more difficult, and if you'll play around with it a little bit, you'll figure out like what is the best way, like where to pull from and stuff to be able to make how many energy levels you need. I will go down here to this one where it's already got it drawn for you and just give you an example of how you would do this. If we've got neon, we know that its atomic number is 10, so we know that it's going to have 10 protons, and we know that it's going to have 10 electrons. And then our neutron count would come from saying 20 minus 10, so we're also going to have 10 neutrons. So we're just going to diagram the electrons. We're not going to worry about anything with the nucleus for these because this nucleus is really small and they've only given us 2 levels. So what we're going to do is we have 10 electrons that need to be diagrammed. So I'm going to use the shapes. I'm just going to try to go really small with them, the smallest I can go, and just drop them in there. So the first level can only hold 2. So I'm going to put 1 right there, and I'm going to put 1 right there. So that's 2 electrons. I still have 8 more that I need to plot. So I'm going to go 2 at the top, go 2 on the left, 2 on the bottom, and 2 on the right. And so now I have 2, 4, 6, 8, 10. So that's how my electrons would be diagrammed for a neon atom. And then if we went to magnesium, for magnesium, it's going to have an atomic number of 12. So our P would be 12, our E would be 12, and then our neutrons would be 24 minus 12 would be 12. So our P and our N would both be in the nucleus, and we could just say 12P, 12N, and then we're going to diagram these electrons. So the first level can only hold 2, so 2. Second level can hold 8. So now at this time we're going to have 10 because the first and the second level are full, but I still have 2 more electrons to place. And you could either put them both together here, or you could place 1 on the top and place 1 on the left. It's just up to you, but I do like them to be grouped together or placed in the locations of north, south, east, west, not just scattered around the atom, because it makes it easier for you to count and me to just visually see that you have it right. So I'm just going to place both of those up here on the top. So I would have 2 plus 8, 10 plus 2 is 12. And you're going to see in some things like where it'll ask you for what, for electron configuration. And I want to explain that real quick, like what electron configuration is. That is where you would explain like how many electrons that atom has. So for magnesium, its electron configuration would be 2, 8, 2. And that's not placing it on there in that text box. Well, I probably should have put a text box somewhere else. I could put it right here and go 2, 8, 2. And that's what the electron configuration would be, because what you're doing is you're saying how many electrons are on each level, and it indicates how many levels it has. So it had 2 on its first level, 8 on its second level, and 2 on the third level. And another important thing to know is that the outermost energy level that's been diagrammed, however many electrons that are on that level, that's called your valence. So magnesium would have 2 valence. Neon would have 8 valence because its outermost shell has 8 electrons on it. So it's all dependent on like its electron configuration. You know, by whatever the last number of electrons that you had, that's what your valence is. Here's another type of diagramming, and really all you do for it is you take the element symbol and you place dots around the element symbol that represent your valence electrons. So just as I'd said right here, like for neon, it had 8 valence. So what you would do is, let's go back and do our shapes again, and then the little dots. So neon had 8. So I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8. And then magnesium had 2 valence, so it would look like this. And then chlorine, it has 17, so it would be 2, 8 is 10, and then you would have 7 on its outer, so it would have 7 around this. Um, this is silicon, and silicon has an atomic number of 14, so that means you would be 2, 8, so 2 plus 8 is 10, and then you would have 4 on your outer energy level. So your valence number would be 4. So when you got down here to the Lewis dot, you could either do 2 on the top and 2 on the left, or you could go 1, 2, 3, 4, whatever works best for you. So when you get over here to this assignment that I've made now, this one's going to have you diagram elements 1 through 18. And so to do this, it explains to you in the little directions that what you're going to have to do is just click on this. And once you've clicked on it, you can go Control C. And then that's a proton. So I'm going to come over here to my nucleus, and I'm going to go Control V. Well, I guess I'll have to drag them once I make them. So I'm gonna have to do that as many times as I would need to. But hydrogen only has 1 proton, and hydrogen only has 1 electron. So that's, oh goodness, kind of did the wrong thing there. But you would take and drag that and put that on the first energy level. That's not quite, it's not dragging for me the way I want it to, sorry. But it would just be on that first energy level is the only place that you would need an electron, and it would just be on there. And I ended up making that super, super tiny because I didn't quite copy and paste it great. But hydrogen in its natural form doesn't even have a neutron because its atomic number is 1 and its atomic mass is 1. So 1 proton, 1 electron, but then when you say atomic mass minus atomic number, 1 minus 1 is 0, so it doesn't have a neutron. So what you'll do is you'll just continue on. You'll also need to fill this information out over here. So like hydrogen symbol would be H, its atomic number would be 1, its atomic mass rounded would be 1, its protons would be 1, its neutron would be 0, and its electron would be 1. So you'll just continue that for all 18 of those atoms. And if you need any assistance or any help, all you have to do is message me and let me know. But I hope this has helped you guys, and you have a better understanding of electrons, protons, neutrons, and how to diagram an atom. Have a great day.